My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 434. In this lecture, I will continue my discussion on moving window for time series data. In this case of moving windows, basically at any time t, your problem looks like this. You have a time, you have a signal that is changing like this. At this time t, just observe this one. This is at time t. Let me say this one as yes. This is time t. Yes. At this time t, you have to determine whether patient would a patient get cardiac arrest in next 15 minutes. Let's assume the task we have just hypothetically is predict cardiac arrest, or I can say heart attack. Predict cardiac arrest or heart attack in next 15 minutes. Would the patient gets heart attack in next 15 minutes? Let's assume that is the task we have. Let's assume this is the current time. Just see, this is the, let me say, this is the current time. Just see this one. This is the, let me assume this is the current let's assume this is the current time we have, this time t. What would I do here? I will discuss with doctor and design all my features, and I would say this is the window of time. Just consider this is my window of time. Let me assume this is my window of time. The doctor might say only look at last 1 second of data and look at the difference between maximum and minimum, or look at how many features, how many times it's beating. Just say that feature one may be max minus min, feature 2 may be how many times it's beating, feature 3, feature 4, something like that. If it is beating abnormally, so doctor will tell you what to look for. Based on that, you design your features. This could be your there may be so many features, max minus min, those features which we discussed, that may be feature 1, feature 2, feature 3. Doctor would say what happens in last 1 second, because your heart beat quite fast, based on doctor's recommendation, based on domain expert. So you could design in such a way that you would take steps for featureizations. Maybe these may be the steps. Feature 1, step number 1, first you define what is the window width. You discuss with by discussing with domain expert. Domain expert is helpful in deciding width of the window. That's what we discussed in our previous lecture. Then you say what are the features in this window that are useful for predicting, let's say it's heart attack. Number 3, each of the features you have, doctor may say max minus 1, max minus min is useful feature. That number of mean crossings may be useful features. The doctor may suggest max minus min is useful, number of mean crossings are important. So you put all these features that you discussed with doctor. Just put all these features, that these are the features. You can put those features here, feature 1, feature 2, feature 3, feature 4. We discussed which feature. It depends on doctor, isn't it? You discuss with doctor that your test empirically becomes your features. Your yi, actually these features, feature 1, feature 2, feature 3, feature 4, something like that, that forms a data point xi. Yi has the patient had the heart attack. Yi says whether a heart attack, your yi is now boolean. That's important. Your yi, your label is boolean, heart attack or not. Heart attack in next 15 minutes or not, isn't it? That's a Boolean variable. That yi is Boolean variable. This is how your data looks like. This is my, what is my data set here? I can say this one, this is xi, this is yi. That is my data set is xi comma yi, isn't it? Yi is Boolean, isn't it? This is how your data look like, and all these features you are getting them from that just a single window. You must understand, we are getting all these features from single window, and this window changes as time passes. Suppose I can say, let me assume, suppose your data looks like this. Just let it be. Let's assume you are at, let me say you are at time t1. You use the moving window here at time t1, isn't it? You come up with feature ideations and predict, but heart continues to beat, right? Isn't it? Heart continues to beat. No. So let's assume you decided that there is no problem. You are at time t2. At time t2, now again you go back and say, this is the window of time that I want to look at. So at any time that you want to understand whether the patient is going to, whether you want to run your machine learning model, you take a window of time, and all the featureizations that you discuss with the medical expert or you learn from medical literature, you can learn all of that and apply to the techniques here, isn't it? Unfortunately, there is no fixed literature here. That's important. All the techniques means, what are the techniques? Techniques like which we discussed: min max, min minus max, min by max. There is mean crossings. Those are techniques come from where will you get? Actually, from this what we discussed here. Just try to recall all these features. You can get by using these features. You can get from a window. By using window only, we are calculating these features. This forms the xi, and this is yi. That is data set, isn't it? xi comma yi, and yi is Boolean in this particular context, isn't it? Now, all the techniques. What are the techniques? The techniques may be max, mean or standard deviation, median, quantile, max min, max minus min, max by min, local maxima, zero crossing. All these techniques come from signal processing. That area is known as signal processing. These are the techniques which are coming from the area known as signal processing, isn't it, Jesse? Signal processing. Yes. There is almost 50 plus years of research. Of course, medical experts have studied this. Medical signal processing people have studied this for 50 plus years. Since collecting this, they spend time on this particular signal processing sort of things. So what is the right featureization depends very much on the problem. There is no hard and fast rule. So oftentimes when you are given a new problem, you should try to read up literature or research. Literature means published. What is literature? Literature means, in this context, published research for determining what is the right feature. Let's assume if you want ECG data to predict heart attacks, just Google search it. Just if you Google search, what happens? ECG data, just in Google type it, ECG data predicting heart attacks. Just see here, that's what I type. Just see, in Google search window, we typed ECG data to predict heart attacks. You are getting so many articles: ECG classification and analysis of heart diseases, identifying heart failures, ECG data, electrocardiography predictors, heart disease detection using ECG waves. You can see so much of literature: ECG signal analysis and prediction of heart, cardiac or disease predictions by analyzing ECG signals, ECG AI, significance of features from some biomedical signals, methods of diagnosing heart diseases based on deep learning. Even there are, just say this is big data analytics in heart attack prediction. You can get so much of literature. Just Google search it. Just what we searched in Google, we searched like ECG data predicting heart attacks, heart attack features. There is some literature here. There is a lot of research study these research papers properly. Topmost university, you can find topmost university research problems. This topmost university problems with data scientist is they with problem data scientist may not expert in this area. For example, I don't understand what is this myocardial. This I don't know. A data science expert or machine learning expert may not aware of these things. Myocardial infarction is one of the deadliest disease patient face. All these things I don't understand. What is this? I don't know what it is. I need to oftentimes scenarios like this, I work with medical experts or I work with somebody who knows this medical stuff. Then I read up, because I know machine learning algorithm. He knows the domain expert, doctor knows or medical expert knows domain experts. I read research papers like this. Once I read research papers like this, if I read research papers like this, I understand what are the methods, what are the ways, what are the types of features, what are the designing techniques. So the features, for what are the features for different situations. By reading this lots of research, only by reading lots of research, you can see what types of data is available. You will be able to design right solutions, or practitioners, or so machine learning expert or machine learning practitioners needs to be ready to read up literature, especially if they are working in domains that they are not their core territories or expertise. If you don't have an expertise, you have to either you have to go through literature or you have to sit with medical experts, isn't it? For example, I don't have any background in medicine. If somebody gives me a medicine problem in medicine, predicting heart attack using ECG, I would spend base reading up existing research literature on understanding what types of features are typically used here, isn't it? Because there is no point in reinventing things. That's important. Of course, in the modern day, thankfully, with deep learning, what's been happening last decade, actually from last 5 years also, since 2012, one of the greatest thing that's happening is deep learning can automatically learn some of the good features automatically from the data. That's why deep learning such a big data, because what is the deep learning techniques can automatically, most of the time it is not fully automatic, deep learning techniques can automatically, most of the time it can learn features. It's not fully automatic. It still requires some machine learning. It can learn automatically, learn the correct featureizations from data for some types of problems, not for all types of problems. It works very well. It works very well for time series data. So lot of medical research has improved dramatically in last few years, because if I just give a signal, instead of thousands of people spending tens of years to compute with the right featureizations, deep learning models can automatically come up with the right featureizations if you have lots of data. The key point here is you need to have lots of data. If you have lots of data, deep learning would find appropriate featureization fairly successful, not always. Just go through this lecture. Though if you have any difficulty, please keep a comment. In my next lecture, I will discuss about Fourier decomposition, or I can say Fourier transform. Thank you very much.